Now that I have the car lift in, I'm thinking levels. It's all levels.
Levels.
Specifically, I'm going to try and make a lift for my dirt bike. So the rough plan is have some angle iron, some 2-inch, couple pieces. I bought a bunch of casters off Amazon. The casters one will go behind and one will go in front. And I'll make some sort of carriage that'll little roll up and down. I have a Harbor Freight electric hoist that I'll repurpose and mount it up top. If you're making something kind of dangerous, you may as well have a few Harbor Freight pieces in it. And then I have some other metal that I'll make basically some forks that'll pick up the dirt bike and raise up and down. Reinforce the walls a little bit, and then I'll attach these angle iron to the wall studs. Everything should be nice and secure. And dirt bike weighs like 250 pounds, so it's not that ridiculous. Shouldn't be that dangerous, actually. I was mostly kidding. And yeah, we'll get started. I have this angle iron trimmed up. This is basically what the carriage is going to ride up and down on, kind of like a track. I trimmed the ends, drilled a bunch of holes in it. I'll put this up and then lag screw it in with these 1/4-inch structural lag screws. I cut out some square tubing for the carriage. This is about what it'll look like. This is all just balanced here. The wheels will go up here. This whole section here will move up and down. Next, I do need to put some thought into the stresses and the strength and the safety of this. So I need to make sure I can carry the load correctly. I can't really put a gusset because the motorcycle needs to take this whole space. And then kind of more of the same, although up here I could put a big gusset, or I could put a connecting beam here, or I could run a connecting beam up there. So I guess I need to brush up on some statics. So it doesn't weigh that much, like 250 pounds for the dirt bike, so that's not all that much. However, there are some long distances involved here, so I mostly want to avoid any force multipliers or long lever arms that would cause high forces. So I hope to solve for all the various pieces using statics, but I did a quick refresher only to get to the end and realize that the structure was indeterminate and unstable, which just means that you can't solve it with the closed form statics stress equations. First off, we have a classic cantilever section here, supported out here, and then all the weight's going to be right here coming down. So that will cause a downward force here and a moment of disjoint. So there's a bunch of online calculators you can use. I actually downloaded one called Beam Boy. If I put those numbers in, this beam has another 2x safety margin, so that's good. Beam 2 is another cantilever, and the force left over from this is a downward 500 pounds and a moment. If you look at the numbers, and this one's shorter than this one, so it shows that the margin of safety is still pretty good for both these sections. Next, I mentioned I wanted to avoid some long lever arms, which you can see some of these long distances involved. It's kind of a weird structure, I realize, because of the way the wall is set up. Okay, so we can see that if I push down on this, it's gonna want to pry this way, and there's some pretty long distances. Going by the principle of transmissibility, basically says when you have these orthogonal loads that you can ignore the offsets in there. So that means I can get rid of these orthogonal sections. And then again this one. And then I end up with about a 1-to-1. The amount of force that goes here will be about the same as the amount of force there. So it won't act like a long pry bar. And the last part to talk about is this section here. Obviously I'm going to have some type of gusset or brace going across. I can't do that on this one because that's where the dirt bike's going to sit, so I have to keep this area open. So then the question becomes, do I want something down here, or do I want something that goes up higher? And what does that mean for the forces? Okay, so since this is a triangle, you can actually use the statics equations for this small section of it. And the way it works is the forces at play are basically proportional to these distances, which kind of makes sense. So as this angle gets lower and lower, the forces can get quite high. And then as this angle opens up and you get longer, the forces come down and they eventually approach the original as this gets vertical, which makes sense. So I think that means the answer is to run this support all the way up to the top. It's 59 degrees difference. Yeah. Okay, so this is starting to take shape. I think it's looking pretty good. I can put the wheels on. Bottom wheel will go about here. So for the top wheel that needs to be behind this, I'm going to have this. And then I'm thinking I'll weld that on. And then I can slide it over the top. Like so. I have everything tacked together. Should be good enough for a quick test. Made 2 of these, as I was talking about. These will slide over to lock the top in. I'm calling that a successful test run. Next, I got to do all the final welding, add some gussets and some reinforcements. I'm going to add some guides to each side to keep it centered. Test number 1. So one issue I noticed with the first test was that this cable, since it's pulling a little bit from the side, tends to bunch up against this edge here, and then every now and then it pops over and makes a little jarring motion. So I'm going to try and fix that. Made a couple updates. I added a second pulley. So now you'll see the cables run up. And the cable feeds into about the center of the spool, so it won't get caught against the edge like before. And then I hooked the left cable way over to the left so that the weight will be more evenly distributed. And now it operates pretty smooth.